solve quadratic equations with solutions that are not real numbers. Let's take a look at this example. X squared is equal to minus 17. Recall, if I have x squared is equal to number like k, from here I can write x is equal to square root of k, or x is equal to minus square root of k. So in this case, I would get x is equal to square root of minus 17, or x is equal to minus square root of minus 17. So let's take a look at square root of minus 17. We need to simplify that. This would be the same as square root of minus 1 times square root of 17. We can separate this to minus 1 times 17. Anybody remember what square root of minus 1 is equal to? We replace that with, that's an imaginary number or complex number, and so you're going to replace that with I. So this would be the same as I times square root of 17, or negative I times square root of 17. So we can write the solution set as plus and minus I times square root of 17. Solve x plus 5 squared is equal to minus 100. We're going to use the square root property. If x squared is equal to k, x would be equal to square root of k, or x would be equal to minus square root of k. So in this case, my x is x plus 5. So x plus 5 is equal to square root of minus 100. X plus 5 is equal to minus square root of minus 100. So we have a negative under the radical. We need to simplify that. So if I have square root of minus 100, this is really the same as square root of minus 1 times square root of 100. So square root of 100 is equal to 10. Anybody remember what square root of minus 1 is equal to? We replace that with I. So this whole thing would be equal to 10I plus 10I. So that's why we get x equal to plus 10I, or x equal to minus 5 plus 10I, or x equal to minus 5 minus 10I. So we can write the solution set as minus 5 plus or minus 10I. Solve each equation. Here we have 5x squared minus 15x plus 12 is equal to 0. We're going to use the completing square method here. The first step is to move this constant to the other side of the equation. If I subtract 12 from both sides of the equation, I would get 5x squared minus 15x equal to negative 12. So here I have x squared minus 3x equal to minus 12 over 5. To complete the square here, first I have to make sure that the coefficient of x squared is equal to 1, which it is. It's 1 here. Then we take the coefficient of x, which is negative 3. We divide it by 2, or multiply by 1/2, and then we square them. So in this case, I have minus 3. We take minus 3, and we multiply it by 1/2, or we divide it by 2. And then we square this whole thing. We always divide by 2 and square them. So in this case, I would get negative 3/2. When I square this, I would get 9/4. So this is a number I need to add to both sides of the equation. This is how we obtain that. So by doing that, the left-hand side not only would be factorable, also would be perfectly square. We get x minus 3/2. So if I factor the left-hand side, you notice that I would get x and x here. So here would be 3/2. Here would be 3/2. And both has to be minus. Notice that if I multiply x times x, I get x squared here. multiply 3 half times 3 half, I have 9/4. If I multiply the two closest term and two furthest term, I get 3 half x. Here we have 3 half x. If I add 3 half plus 3 half, what do I get? I would get this middle term here. 3 plus 3 would be 6/2, which is equal to 3. So everything is there. We complete the square. Now I can perform the square root property to solve for this. Here we go back to the fact that if x squared is equal to any number k, x would be equal to square root of k, or x would be equal to minus square root of k. So in this case, your k, or your x, is this expression, x minus 3 half. So you conclude that x minus 3 half must be equal to square root of this number, or x minus 3 half must be equal to minus square root of this number. To solve for x, you need to add 3 half to both sides of the equation. So you would get x is equal to 3 half plus this number. So let's simplify this number here. We have square root of minus 3/20. What is that equal to? So if I separate this, that would be square root of minus 1. I'm going to take that minus 1 out. Then I would go ahead and write this as square root of 3/20. We know that square root of minus 1 is equal to I. I'm going to replace I here. And here would be square root of 3 over square root of 20. But what is square root of 20? That is the same as 4 times 5. So square root of 4 times square root of 5. Now square root of 4 is perfectly square. That would be just 2. So that would be 2 radical 5. So this whole thing would be equal to I times, at the top of the fraction you have square root of 3. At the bottom of the fraction you get square root of 20, or you can write it as 2 radical 5. 2 radical 5. So we do need to eliminate this radical 5 though. We cannot have radical 5 here. In order to eliminate radical 5, we need to multiply top and bottom of the fraction by radical 5 over radical 5. If I do that right here, radical 5 over radical 5. Now this whole thing, I'm going to copy this right there. What do we have so far? We have I at the top of the fraction. We have radical 3. We have radical 5. At the bottom of the fraction, I have 2 times radical 5 times radical 5, which would be radical 25 or just 5. We rationalize that. So the bottom of the fraction get 2 times 5 is equal to 10. At the top of the fraction I get I times radical 3 times radical 5 would be equal to radical 15. And that's why you have I radical 15 over 10 here, as you can see. To simplify radical 3 over 20, we can separate that into radical minus 1 times radical 3 over 20. We replace radical minus 1 to I. Here we have radical 3 over radical 20, which is equal to radical 3 times radical 4 times radical 5. Here would be 2 radical 5. To rationalize this, we need to multiply top and bottom fraction by radical 5 over radical 5. So now you see that radical 5 times radical 5 would be radical 25, or just 5 times the 2 what's right next to it would be equal to 10. At the top of the fraction with I radical 3 times radical 5 is equal to radical 15. So the answer would be x. If I simply just add 3 half to both sides of the equation, I can isolate x. X would be equal to 3 half plus this result, or 3 half minus this result. So these would be my solution set.